Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and the title of this lecture is Computing Indefinite Integrals and Solving Initial Value. In the last lecture we started looking at indefinite integrals, and in that lecture we focused on notation, concepts, and properties of the indefinite integral. Here we start actually computing some of them, and we start off with some basic indefinite integral formulas. The first formula we're going to look at is when we take the integral of a power of x. So here we have the indefinite integral of x to the n power dx. You could think about this as being an example of this would be the indefinite integral of x squared dx. And the formula is going to be x to the n plus 1 all over n plus 1 plus c, where c is the constant of integration. This formula holds for n not equal to 1. Now I want to remind you that you can check these formulas with the derivative. If you take the derivative of the right hand side, you should get the integrand. Let's check and see. If I take the derivative of x to the n plus 1, the n plus 1 goes in front. It will cancel with this n plus 1 in the denominator, and you subtract 1 and you'll have x to the n, and the derivative of a constant is 0, so that checks. This formula holds for n not equaling minus 1. We'll have a different formula for that, because if n was minus 1, we'd be dividing by 0, and that will not work. A special case of this formula is when we integrate a constant with respect to x. Now, you can jerk the constant through the integral. I told you I would do that 10 times out of 10, so I should do it now. And then what I'm left with is 1 dx. But 1 is the same thing as x to the 0, and so I add 1 to the exponent and divide by the new exponent, and I get x. So this integral, where k is a constant, is kx plus c. Now you want to start making a list of these formulas, beginning with the first two here. The list will grow rapidly and should be committed to memory, and we're going to be using those extensively throughout the balance of the course beginning today. Alright, so here are some integral formulas for you to commit to memory. Since the derivative of the cosine of x is negative sine of x, that means that the antiderivative, or the indefinite integral of sine of x dx, is negative cosine of x plus c. Since the derivative of the sine of x is the cosine of x, the indefinite integral of the cosine of x dx is equal to the sine of x plus c. Since the derivative of the tangent of x is equal to the secant squared of x, then the indefinite integral of the secant squared of x is equal to the tangent of x. Since the integral of since the derivative of the secant of x is the secant of x times tangent of x, then the integral of the indefinite integral of the secant of x tangent of x dx is the secant of x plus c. Since the derivative of the cotangent of x is equal to the negative cosecant squared of x, that means that the integral of, the indefinite integral of, the cosecant squared of x dx is equal to the negative of the cotangent of x plus c. And since the derivative of the cosecant of x is equal to minus cosecant of x cotangent of x, that means that the indefinite integral of the cosecant of x cotangent of x dx is equal to minus cosecant of x dx plus c. We also have some other integrals that we have learned. Since the derivative of the x of e to the x is e to the x, this formula holds. Since the derivative of a to the x, where a is not e, it even holds for a equal e, so the indefinite integral of a to the x dx is a to the x over ln of a plus c. And since the derivative of the logarithm of the absolute value of x is equal to 1 over x, that means that the indefinite integral of 1 over x dx is equal to the natural logarithm of the absolute value of x plus c. And this is the case where n was minus 1. We talked about inverse trig functions. I'm going to list a couple of them here. Since the derivative of the arctangent of x is 1 over x squared plus 1 dx, that means that the indefinite integral of 1 over x squared plus 1 dx is the arctangent of x plus c. Since the derivative of the arcsine of x is equal to 1 over the square root of 1 minus x squared, that means that the indefinite integral of 1 over the square root of 1 minus x squared dx is equal to the arcsine of x plus c. We also have a bunch of identities, derivative formulas, and consequently indefinite integral formulas holding for the hyperbolic trigonometric functions. And there are even more formulas, but this is sufficient for us to get started and actually calculate some of these yet in this lecture. So I'm going to ask you to please evaluate the following indefinite integrals. There are 6 of these. You should write them down and do them. You know what to do. I'm also going to ask you to check your answers by using the derivative before you tune into the subsequent video and we see how you did.